This problem is asking us to determine the end behavior of a polynomial. So polynomials are either even powers or even degrees or odd degrees. If we have a leading coefficient that's an even power, that means our shape is going to look parabola-like. It's either going to be happy or it's going to be sad depending on the lead coefficient. And if x happens to be raised to an odd power, we have what I like to call John Travoltas, which either go up like that or down like that. I call them John Travoltas because it kind of looks like he's staying alive, staying alive. Okay, so what's our first example? F of x equals 4x to the fourth plus etc. It turns out with end behavior, what happens as we go towards infinity, the only thing we need to pay attention to is the leading term, the term with the highest exponent. So look at the exponent of that term. That's a 4, and that's an even number. So that means we're in the first case. It's either going to be a upward opening parabola-like shape or a downward opening parabola-like shape. The way to tell if it's opening upward or downward is by looking at the leading coefficient. In this case, the leading coefficient is a positive number. So positive, happy attitude, it's going to be smiley. It's going to look like an upward opening parabola. So it's going to look a lot like this. Again, not exactly. Fourth degree is a little bit skinnier. It's more squashed. But we get this kind of impression that it's moving upwards on the edges. So the way that we usually notate this is to say as x goes towards infinity, we have that y goes towards infinity, which means that as x rises, that would mean that as we're going to the right, we rise. So we'd say rises right. And then as x goes towards negative infinity, on this end we also have an extension upward. So we'd say that y goes towards infinity, which would mean it rises on the left also. So this one rises right, rises left. Okay, for the second one, we have 2x to the fifth plus etc., etc., etc. So in our leading term, we have a power that is an odd number, which means we're getting a John Travolta type shape, and our leading coefficient is positive. So that means it's going to be moving upward on the right hand side. So very roughly it's going to look like this. So as x goes towards infinity, the y is going towards infinity. So this one is going to be rises right, and then as you go towards negative infinity, this direction, it's going downward. So we'd say as x goes towards negative infinity, y goes towards negative infinity. So it falls to the left. So we have a rises right, falls left. Okay, why don't you try one example on your own here? Pause the video and see if you can get, no, I guess two of them, sorry. See if you can get the answers to these two polynomials, polynomials here. So assuming you paused and gave it a shot, notice our leading term is this one, which has a even power but a negative leading coefficient. So that means it's going to generally look like this. It's an even power, so it's parabola-like, but this time it's opening downward. So as x goes towards infinity, y is going to go towards negative infinity. So it falls to the right, and then as x goes towards negative infinity, we see that y also goes towards negative infinity. So we'd say it falls left. So this one's falling left and falling right. And then for our last example, we have negative 5x to the seventh. So we have an odd power, John Travolta, negative version this time though, so that means it's going to be going downward like this. And so if we look at a shape like that, we can see that as x goes towards infinity, y is going towards negative infinity, falls right, and as x goes towards negative infinity, y goes towards positive infinity. So it rises to the left.